Today I will discuss that what is coefficient of variation, why we use it, why it is important, and what is the specific situation where we use coefficient of variation to measure the dispersion. So basically coefficient of variation is a measure of dispersion, or we can say that this is a measure of consistency of the data or scatteredness of the data. There are so many other measures of dispersion are available to compute the dispersion, like quartile deviation, standard deviation, mean deviation, range. And we know that this thing, that is standard deviation, is also called the best measure of dispersion. So why we talk about coefficient of variation? The question is this. So student, I would like to say you this, coefficient of variation is a relative measure. This is a percentage measure, and the most important thing about this measure is that it is a unitless measure. So if we simply want to calculate the dispersion of any series, then we can apply standard deviation, mean deviation, any formula to calculate the result. Or if we want to compare two or more than two series in respect of their dispersion, we can use standard deviation, mean deviation, or any other measure of dispersion. But if we have a situation where we have to compare dispersion of a two or more than two series with different variables, different variable with different units, then in this situation the only solution is to compute coefficient of variation to compare the consistency of the different series. Now we take an example to understand these things. So we are talking about coefficient of variation. Okay, let we have a two series of x and series of y. Here x is a height of person of a colony A. Okay, this is a height of the person of any colony A, and y is height of person of colony B. We have two colonies A and B, and we measure the height of the person of colony A and the person available in colony B. The height is given by y. Then we have some data like x, x1, x2 up to xn, and y, y1, y2 up to ym. Simply we calculate the standard deviation of A series and the standard deviation of B series. The standard deviation of this series is, we can write sigma A, and this is sigma B. If sigma A is greater than sigma B, then we conclude that dispersion of series A is greater than B. B series is more consistent than series A. Now we take another situation. Let we have a data of two series x and y, and we want to compare which one is more consistent, and the variables are x is family size of any colony A, and y is the income of family in the colony B. Okay, the data of x is like x1, x2 up to xn, and the data of y is like y1, y2 up to ym. So in this situation we cannot compare the consistency or the dispersion via standard deviation, mean deviation, or any above said method. There are different type of unit of the variable. X is a family size. Here the unit is number of member 1, 2, 3, 4, and in this situation income are like in thousand, in lakhs. If we calculate standard deviation of this series, then it came in 4 member or 5 member and so on. And for this series the standard deviation come like 80,000, 20,000, 25,000, 34,000 and so on. So it is very difficult, and we can say that it is not possible to convert the member into 1000. And here we can say that because when the unit of the series are different, then we need a unitless measure. Okay. Now we talk about the formula of coefficient of variation. So it is denoted by, first we write the formula. It is denoted by CB, and the value of CB is sigma upon arithmetic mean into 100. Here we see the formula of coefficient of variation. Coefficient of variation is denoted by C and V and defined as the ratio of sigma over x bar into 100. Okay? Sigma is the standard deviation of the series, x bar is the arithmetic mean of the series. X bar is the arithmetic mean of the series, and this is a unitless measure and in form of percentage. So for the comparison of the consistency of two or more than series, when the variable of the series have the different unit, coefficient of variation is a suitable measure.